Hi everyone, and our topic for today is all about linear function. Linear function is defined by f of x equals to mx plus b, where m and b are real numbers. Each graph is a line with slope m and y-intercept b. If m is not equal to 0, then the degree of the function is 1. If m equals 0 and b is not equal to 0, then the degree of a function is 0. If m equals 0 and b equals 0, then the degree of the function is not defined. So therefore, linear function, we have a given graph, the given graph C line, and we have the slope and y-intercept. We have this symbol, and this symbol is f of x, or it can be function of x. F of x, it means y. Y, it means f of x. Output, y, f of x, y, f of x means output. And they call it also dependent variable. So f of x means y, output, dependent variable, or they call it functions of x. Some examples of linear function in different forms are: number one, we have f of x equals 3x plus 4, g of x equals negative x, 3. Number 3, we have y equals 1 half x minus 1, 2x minus y equals 5, and we have 3x plus 5y minus 5 equals 0. Wherein the first three example, 1, 2, and 3, these are written in the form of f of x equals mx plus b, or y equals to mx plus b. So f of x means y. Now let us determine the value of m and b. So number one, your slope, your m, equals 3, and b, that will be your y-intercept, equals 4. Number two, we have m equals to negative 1, and b equals 0. Then we have number 3, your slope, that will be your m, equals 1 half, and your y-intercept means b equals negative 1. But number 4 and 5, these are also a linear function, but we need to change this given form to standard, the slope intercept form. So number 4, we have 2x minus y equals to 5. If you still remember about how to rewrite the standard form to slope intercept form, the linear equation in two variables. So simply, all you have to do is you transpose 2x, and then you isolate the y on the left side. So therefore, if you transpose positive 2x, it will become negative 2x. And then copy negative y, then equals negative 2x plus 5. But this time, your y is negative. Now, all you have to do is you divide both sides of the equation by negative 1 to eliminate the negative sign. So we have divided into negative 1. Then you cancel out. And therefore, we have positive y equals 2x minus 5. And wherein your slope and b, we have the slope, that will be your m, equals 2, and b equals to negative 5. Next, we have number 5. And number 5 is written in the form of general form. Now, all you have to do is you change this given form to slope intercept form. So you transpose 3y, then transpose negative 5. Then you isolate y on the left side. And therefore, we have negative 3x, transpose positive 3x. Then change the sign. It will become negative 3x. negative 5, it will become positive 5. Then we have bring down 5y. Then eliminate 5, divide both sides of the equation by positive 5. So we have 5, then cancel out. Then we have cancel out. Then we have y equals negative 3x over 5 plus 1. Then your slope is negative 3 over 5 and your y-intercept is positive 1. So these are an example of linear function in different forms. The highest exponent or degree of x is 1. So take note that the highest exponent, or they call it the degree of x, is 1. And they call it linear function. These are not linear function. We have f of x equals to negative 4. G of x equals to 10x squared positive 7x. Y equals 3 over x minus 8. 2x cubed minus y equals 4. F of x equals 3x squared plus 5x plus 1. Number 1, the slope m is 0. So therefore, this example is not a linear function. Number 2, the highest exponent or degree of x is 2. And always remember that the highest exponent or the degree of x is 1. They call it linear function. But number 2 is not a linear function. Number 3 is also not linear function since it cannot be expressed in the form of y equals to mx plus b because x is in the denominator. Then we have number 4, the highest exponent or degree of x is 3. And the last one, the highest exponent or degree of x is 2. So these are not linear function. Remember, letter A, f of x means the value of f at x. It does not mean f times x. Then we have letter B, letters other than f, such as the capital letter G and H, or the small letter G and H, can also be used. So it can be G, H. The letter C, the graph of a linear function is a straight line. Take note that the graph of a linear function is a straight line. But a vertical line is not the graph of a function. So again, the vertical line is not the graph of a function. So we have only a straight line, but not the vertical line. We have a linear function can also or can be also described using its graph. We have the example, determine the values of the function f if f of x equals to x minus 2 at x equals to negative 1, 0, and positive 1. So we have the solution here. So if x equals to negative 1, then f of x equals 2x minus 2 becomes now f, then change x, and we all know that your x is negative 1. Now you change x to negative 1. Then f of negative 1 equals 2, then change x to negative 1, then minus 2. Then simplify, f of negative 1 equals 2 multiplied to negative 1, and the answer is negative 2. Then copy negative 2. Then f of negative 1 equals negative 4. The given ordered pair, we have negative 1 and negative 4. Your x is negative 1 and your y or your f of x is negative 4. Note that an ordered pair xy can be written as x f of x because your f of x means y. So we have f of xy, it's similar to x, f of x. Next, what if your x is 0? Then what will be the value of f of x? So f of 0 equals to 2x minus 2. Then f of 0 equals to 2. Then you change x to 0 because the value of x is 0. Then multiply 2 times 0, then negative 2. And therefore, the answer is f of 0 equals to negative 2. Then your given ordered pair is 0 and negative 2. Your x is 0 and your f of x is negative 2. Then we have x equals positive 1. Then again, we have f, then change x to 1. F of 1 equals to x minus 2. F of positive 1 equals to 2. Then change x to positive 1. Then negative 2. Then 2 times 1. And the answer is 2. Then minus 2. Then f of 1 equals to 0. Then your order pair is 1, 0. Your x is 1, and therefore your f of x, your f of 1 is 0. Draw the graph of f of x equals to 2x minus 2 using this Cartesian plane. And these are your given points. So we have negative 1, negative 4, then 0, negative 2, then 1, 0. Then we have a table of values. So use a table of values. Then your x, that will be your negative 1, 0, and then 1, positive. F of x means y. So output, then dependent variable. So we have negative 4, negative 2, 0. So the first one, we have negative 1, negative 4. So you move 1 unit to the left side of the y-axis and 4 units down or below the x-axis. So 1, then 1, 2, 3, 4. So therefore, this will be your given point. And we have negative 1, then negative 4. Next, we have 0 and negative 2. So your x is 0, and we have your negative 2, your y. So you move 2 units below the x-axis. So 1 and 2. So therefore, this will be your 0 and negative 2. Next, we have 1 and 0. Your x is 1 and your y is 0. And therefore, this will be your given point, 1, 0. Then after you plot the given points, so now all you have to do is you draw a line. So we have a straight line. Now, arrowheads indicate that the graph of the functions extends in both directions. These arrow heads, an infinite direction. It extends to the left and right without bound. And then the domain D of the function is the set of real numbers. So we have the domain is a set of real numbers. It extends upward and downward without bound. And the range R of the function is the set of real numbers. So your domain and range are a set of real numbers. So this will be the graph. Then we have a linear function can be also described using a table of values. Now we have the example. Now look at this example. We have the same example. So this one is negative 1, 0, 1, then negative 4, negative 2, 0. And let's say we add negative 2 and negative 6, 2 and 2. Now, if you observe that your x, negative 2, negative 1, 0, then 1 and 2, then we have you add positive 1, then it will become negative 1. So the difference between the two x or between the two numbers is positive 1. And then if you subtract 0 and negative 1, or I mean, you if you add positive 1, so therefore it will become 0. So negative 2 plus 1, it will become negative 1. Then negative 1 plus 1 is 0. Then if you add another positive 1, then positive 1, 0 plus positive 1 is 1. Then 1 positive 1 is 2. So we have a constant amount. We add a constant amount. So we have positive 1, then negative 2, negative 1, 0, 1, 2. And how about the f of x? Now, if you observe that we have negative 6, then negative 4, then negative 2, 0, and 2. So therefore, we add positive 2. Negative 6 plus 2, negative 4. Then another positive 2, negative 4 plus positive 2 is negative 2. Then 0, then 2. Adding by, or you add 2. So it means that as the x coordinate increases by 1, so we have increases by 1 unit, the y coordinates also increases by 1 by 2. So again, the x coordinate increases by 1, the y coordinate also increases by 2. Since the x and y coordinates increase by constant amounts, this table of values illustrate a linear function. So we have a linear functions. If the x and y coordinate increase by constant amounts, and we call this linear function. Next, we have the example. Determine which among this table of values illustrates a linear function. Then look at number 1. 1, 2, 3, 4, 5. Then 2, 5, 8, 11, 4. So if you observe that we add 1, increase by 1 unit. 1, then 1 plus 1, 2, 2, 3, 4, 5. Then your f of x increase with the same amount. We have positive 3. So add 3. So 2 plus 3, 5 plus 3, 8. Then 8 plus 3 is 11. And therefore, this one is, they call it linear functions. Why? Because since the x and y coordinate increase by constant amounts, these table values illustrate a linear function. So we call this linear function because the x and y coordinates increase by constant amounts. Next, how about number 2? This one, we have increase 1 unit, but your f of x is not increased with the same amount. We have 1, then 3, then 5, 7, and therefore, since the x and y coordinates do not increase by constant amounts, this table values does not illustrate a linear function. So it means that this table is not a linear function. Then we have number 3, we have the same increase by constant amount by 5 units. So 0 plus 5 is 5, then 10, 15, 20. And how about the f of x? And the f of x, we have 100 units. So increase by constant amount. And therefore, since the x and y coordinate increase by constant amounts, and this will be an example of linear function. So this table is, they call it linear function. Now we have the example here. Determine whether the following is a linear functions or not. Write LF if it is a linear function, or NLF if it is not a linear function. Now look at number 1. F of x equals 3x plus 4. And therefore, this one is linear function because the degree, or the highest exponent or degree of x is 1. So we have LF, linear function. Then number 2, we have y equals to x over 6 minus 8. And they call it also linear function because this form is written in the form of y equals to mx plus b. Next, we have number 3. Observe x and y, f of x or y. The negative 2, negative 1, 0, 1, 2. So we have increased 1 unit. But how about your f of x? 4, 1, 0, 1, 1. So therefore, this one is not linear function because the x and y coordinates does not increase by the same amount. Then we have X, -5, -3, -1, 1 and 3, then 6, 5, 4, 3, 2. Then they call it linear function. So this number 4 is linear function. 6, 5, 4, 3, 2. We have -5, then -3. So 2 units. -2, then -2 plus 2, then we have +1, then 2, then 3. Then number 5, we have this given graph, and therefore this graph is, they call it linear functions because it is not a vertical line or it is not also a curved line. We have a straight line, and we have, this example is linear function. Thank you for watching, and I hope you learned something. Bye.